This image shows places that are changing in Greenland. The red blotches show areas of increase in speed, and the blue blotches areas that are stable. And areas that are colored green are slowing down, but there's none in this view graph, so you don't need to look for green blotches. We reconstructed the mass balance of the ice sheet in the last 50 years. So we have a lot of satellite data from the 90s. We have a little bit of data from the last IGY, the International Geophysical Year from the 1950s. And we correlated the change in discharge of the glaciers with the change in runoff, change in input. And we find some kind of correlation which we use to reconstruct how the mass balance of the ice sheet evolved in the last 50 years. You see this rapid decrease here. It was close to balance, close to zero in the 70s, and it was losing mass in the 60s when climate was a little bit warmer. Now what's important from this exercise is what we find that 2/3 of the loss in Greenland is due to the glacier speed up. Glaciers flowing faster, and only 1/3 is from runoff. That's very important. I know the press likes to tell the public that the green ice sheet is melting, and I get more and more annoyed with that because they think the public is not educated enough to understand beyond that, you know, that there could be something else than just the melting of the ice. The melting of the ice is a slow process. A glacier speed up is something that can discharge ice tomorrow at 2 or 3 times the rate it was doing it before. This also means that if you model the ice sheet without accounting for glacier changes in speed, you might underestimate the changes in Greenland by a factor 3 if you only look at the melt pattern and you ignore the fact that the glaciers could speed up. And this is in fact what has been done in all the international IPCC assessments. The models that were used in this assessment do not allow for a change in glacier speed. So we see that in Greenland, this is actually the dominant control on the evolution of the mass of the ice sheet. So in a way, coming out of this lecture, I would like you to think that the green ice sheet is, yeah, it's melting, but it's also sliding faster to sea, and this is why it's losing so much mass. This is a plot of the different estimates of the mass loss in Greenland. That's why there's negative values here. So because there's a lot of values published in the literature, and you see there's a lot of spread between them, and this is done on different years for different time periods. So the result from the mass budget, the INSAR survey as shown here, you see this decrease since the 1990s. The altimetry results stand a little bit higher because they don't survey the coast completely. They miss a lot of areas. If they miss a glacier, they miss the whole mass loss from that glacier. And then the yellow blotches, this is from GRACE data. This is from Isabella. And you see that you see also this trend in mass loss in the GRACE data, and very good agreement with the INSAR data in the more recent years. Now, all these data show a rapid increase in mass loss of the Greenland ice sheet despite the spread in these values. So the mass loss is accelerating. The mass loss has an acceleration rate of about 20 gigatons per year square. In 2007, the mass loss was 280. That's 100% of the net input of the ice sheet. So basically, you put 280 gigatons of mass, and I'm including the runoff in that. You're adding mass to the Greenland ice sheet. You remove that, and you take that much, and you remove it too. We had a meeting in Cambridge, I think it was just 3 years ago, where one of the chairmen asked the audience how many thought that the Greenland ice sheet was in balance. And a lot of the audience said, "Oh, it's in balance." Some people even waved, like, "You better not disagree with me." How many of you think it's 10, 20% in balance? And maybe a third of the room raised their hand. Third plus a half, I'm not there, yeah. And then he said, how many think that it could be 50% out of balance? There are very few hands. I raised my right hand and my left hand. And I asked Isabella to raise her hand too, but this seemed outrageous at the time, to say that the green ice sheet could be 50% out of balance. It's outrageous. You must be insane. Well, no, it's 100% out of balance.